Today also we are continuing the same topics, circles, and especially the problems on the basic properties of circles. Problem number 16. The two circles x square plus y square plus 2ax plus c is equal to 0 and s is equal to, and s dash is equal to x square plus y square plus 2bx plus c is equal to 0. Touch each other if and only if 1 by a square plus 1 by b square is equal to 1 by c square. 2. 1 by a square minus 1 by b square is equal to 1 by c square. 3. 1 by a square plus 1 by b square is equal to 1 by c. And 4 is 1 by a square minus 1 by b square is equal to 1 by c. Right. And you know that, of course, s is equal to 0, s dash is equal to 0. So the solution is the two s is equal to 0, s dash is equal to 0 touch each other if and only if the s minus s dashed is equal to ax minus by is equal to 0 is a common tangent. At the point of contact, at the point of their contact. And you know that a line touches a circle if and only if the distance of its center from the tangent line must be equal to the radius. And you know that s minus s dash is equal to 0 implies touches if and only if the distance of the center of one of the circles from ax minus by equal to 0 is equal to the radius of the circle. So therefore, the one center circle is a comma 0, and radius is square root of a square minus c. So therefore, a into a minus b into 0 by square root of a square plus b square is equal to root over a square minus c, radius. That implies a to the power of 4 is equal to a square plus b square into a square minus c. So that will give that a power 4 is equal to a power 4 minus a square c plus a square b square minus b square c. So that is if and only if a_4 will cancel. So therefore a square b square is equal to c into a square plus b square. C into a square plus b square. That if and only if 1 by c is equal to a square plus b square by a square b square, which is equal to 1 by a square plus 1 by b square. So therefore answer is option number 3. We go to the next problem. In this problem, you are given a fixed point on a circle, and the length of the intercept of the circle on x-axis is a constant length of 2a. Then he wants to the actually locus of the center of the circle, but I have given only because you have to prove the reverse also. So that's why the center lies on the curve. I have given the, and the options are, you are given that x square plus 2by plus b square minus a square equal to 0. Second option, x square minus 2by plus b square minus a square equal to 0. And third is x square plus 2by plus b square minus a square equal to 0. And fourth is x square minus 2by plus a square minus b square equal to 0. Now you take, let C is equal to center. 𝗓𝗃 be the center. And AB is equal to 2A is intercept of the circle on the x-axis, of the circle on the x-axis. Okay. Now, M is the draw CM perpendicular to AB, so that AM is equal to MB, each is equal to A, because you know that the perpendicular drawn from the center of a circle on its chord always bisects the chord itself. So therefore AM is equal to MB is equal to, each is equal to A because of length 2A. So because M is the midpoint of AB, AM is equal to MB is equal to A. Now you can see that AC is equal to the radius, and also, so therefore what you will get is k square plus a square is equal to AC square, that is also equal to, this is also radius R, that is also equal to h square plus k minus b whole square. Now if you simplify that, k square will cancel, and so you will get h square minus 2bk plus b square minus a square equal to 0. So that means that is hk lies on the curve x square minus 2by plus b square minus a square equal to 0. So therefore answer is option number 2 itself. See, the 18th question is simple, nothing but you are given two circles and you are asked to find the number of common tangents to both of the circles. And you are given two circles, then any one of the four conditions may happen. 5 conditions actually. The two circles do not intersect, do not touch each other. This is the case. Here the two circles are not intersecting. In this case, there will be 4 common tangents. 2 are direct common tangents and 2 are the transverse common tangents. And please remember that the transverse common tangents, the point of intersection of transverse common tangents divides the line joining the centers in the ratio of their radii. Now, if the two circles touch each other externally, this is A and B, R1 and R2. So, two circles touch externally if and only if the distance between their centers is equal to sum of the radii. Sum of the radii. Now, two circles intersect in two distinct points if and only if the distance between their centers is less than sum of the radii and greater than the difference of the radii. Now, if one circle, if the two circles touch each other internally, there is only one common tangent, and this case happens when AB is equal to the difference of the radii. So, these are the four cases actually, but now we will see that is A is equal to 0, 0 and R1 is equal to 2, B is equal to 3, 4 and R2 is equal to square root of 3 square plus 4 square plus 24. So, that is nothing but 16 plus 9, 25 plus 24, 49. So, which is equal to so. Now, distance between the centers AB is equal to square root of 3 square plus 4 square, which is equal to 3 square plus 4 square, which is 16, 5. See, AB is equal to 5 and this is R2 minus R1. So, therefore, the two circles touch internally. So, therefore, only one tangent. So, answer is option number 2. See, the problem number 19 will give you that you are given two circles, out of which one circle is x square plus y square is equal to b square and another circle is x square plus y square minus 2x plus a square minus b square equal to 0. And if this line y is equal to mx minus b into square root of 1 plus m square is a common tangent to both the circles, then what will be the value of m? A positive value of m. He is asking also positive value of m itself. Okay? Right. The solution is, it is known that y is equal to mx minus b into root over 1 plus m square always touches the circle S is equal to x square plus y square minus b square equal to 0. Now this also touches s dash is equal to 0 if and only if the distance of its center, the distance of its center a comma 0, its center a comma 0 must be equal to the radius of the circle. The radius of the circle, namely a square minus a square plus b square is equal to b radius. So, that is modulus of MA minus of a comma 0, MA minus 0 minus b into root over 1 plus m square by root over 1 plus m square is equal to b, itself. So, that implies ma minus b into root over 1 plus m square whole square is equal to b square into 1 plus m square. If you simplify this one, you will get m square a square is equal to m square a square minus 2abm into root over 1 plus m square is equal to 0. That is if and only if m square into a square minus 4b square is equal to 4b square. So, that will give you that m is equal to 2b by square root of a square minus 4b square. You expand the brackets, you simply a plus b whole square. If you expand and simplify it, you will get m square into a square minus 4b square is equal to 4b square, or that is m is equal to 2b by root over a square minus 4b square. So, answer is option number 1. Problem number 20. Here in the problem number 20, you are given two circles with radii 2 and 3 and centers A and B. And he has asked that if P is the point of intersection of the transverse common tangents, and you know that transverse common tangents intersect on the line joining the centers. If P is the point of intersection of transverse common tangents, he is asking the distance AP. AP is to PB is equal to R1 is to R2. And see, the point of intersection of transverse common tangents, they divide the line joining centers in the ratio of the radii internally, and common tangents, direct common tangents, they divide the line joining the centers in the ratio of the radii externally. And all of you know that is a theorem in intermediate circle chapter. And this is 2:3. So, that means 3AP is equal to 2PB, and this is, we can write 2 into PB can be written as AB minus AP. So, that is 2 into 7 minus AP. So, therefore, 5AP is equal to 14, or AP is equal to 14 by 5. So, the answer is option number 1. Problem number 21. You are given two quadratic equations, and the first equation roots are x1 and x2, where x1 is greater than x2, he has given. And second quadratic equation roots are y1 and y2, and y1 is greater than y2. Now, he is asking the equation of the diameter, the equation of the circle described on A x1 y2 and B y2 x1 as a diameter, extremes of a diameter. Options are 8x square plus 8y square plus 48x plus 6y minus 65 equal to 0, and 8x square plus 8y square minus 48x minus 6y minus plus 65 equal to 0, x square plus y square minus 48x minus 6y plus 72 equal to 0, and x square plus y square minus 17x minus 5y plus 6 equal to 0. We find the roots of the both equations. So, the roots of 2x square minus 5x plus 2 equal to 0 are simply 2 and 1 by 2. So, therefore, x1 greater than x2. So, implies you take x1 is equal to 2 and x2 is equal to half. That is. Now, again, the roots of the second equation. The second equation is 4y square minus 17y plus 4 equal to 0. are 4 and 1 by 4. So, because y1 greater than y2 implies y1 is equal to 4 and y2 is equal to 1 by 4. So, the roots of the first equation are 2 and 1 by 2. So, 2 is greater than 1 by 2. So, therefore, x1 is equal to 2 and x2 is equal to half. And roots of the second equation are 4 and 1 by 4. So, y1 greater than y2 implies y1 is equal to 4 and y2 is equal to 1 by 4. Now, we are given that. So, A is equal to x1 by 2 means 2 comma 1 by 4 and B is equal to B is y1 comma x2 means y1 is 4 and x2 is equal to half. This is. And all of you know that the equation of a circle whose diameter, extremities of a diameter x1 y1 and x2 y2 is x minus x1 and x minus x2 plus y minus y1 into y minus y2 is equal to 0. That is a result. So, therefore, equation of the circle described on AB as diameter is x minus x1 x minus 2 into x minus 4 plus y minus y1. Y minus y1 means y minus 1 by 4 into y minus half. x1 by 2 means 2 comma 1 by 4 and y1 x2 means 4 comma 1 by 2. So, that means x square minus 6x plus 8 plus y square minus 1 by 4 plus 1 by 2 into y plus 1 by 8 is equal to 0. So, that means 8 is the LCM. So, that is what you get is 8 into x square plus y square and minus 48x and this is C 2 plus 4 6y plus 8 into 8 plus 1 by 8 plus 1 by 8 means what it will be 64 plus 1 65 into 8 you will get 65 is equal to 0. So, this is the equation required circle equation. So, answer is option number 2. See problem number 22. This is asked in 2011 mains, this problem. So, you are given two circles of which one circle center is the origin and radius C and another circle passing through origin and radius is a by 2, that is x square plus y square is equal to ax. Now, if these two circles touch each other, then what is the relation between A and C? He is asking relation between A and C, right? And you know that when two circles touch at a point P, then the line s minus s dash equal to 0 is the common tangent, at the common point, at the point P. So, now here s minus s dashed is nothing but ax minus c square is equal to 0. So, therefore, s minus s dashed is equal to 0 touches if and only if the distance of the center of one of the circles is origin. So 0 into A or A into 0 minus C square by root over A square is equal to radius C. So that implies C square is equal to C power 4 is equal to C square A square. So this shows that C square is equal to A square. So that implies mod A is equal to C because C is positive. Since C is positive. Actually what you look at is C square is equal to plus or minus A square. But C is positive. So you have to take mod A is equal to C itself. Answer is option number 1. See, you are given a circle and a line, and the line is intersecting the circle in two distinct points. Then he is asking that parameter, the value of the parameter m. M lies in the so and so interval. Okay? And everybody knows that a line intersects a circle in two distinct points if and only if the perpendicular, the length of the perpendicular drawn from the center onto the line must be less than the radius, must be less than the radius itself. So therefore, so here you are having that is, so distance of 2, 4, distance of 2, 4 onto the line, 2, 4 onto the line, 3x minus 4y minus m equal to 0 must be less than the radius phi. So that is modulus of 3 into 2 minus 4 into 4 minus m by square root of 3 square plus 4 square less than 5. So that implies, see, minus 16 plus 6 10. So 10 plus m, mod 10 plus m is less than, this is 5 into 5, 5 square. So that implies minus 25 is less than m plus 10, it is less than plus 25. So that is if and only if minus 35 less than m less than 15. So therefore answer is number 2 itself. Minus 35 less than m less than plus 15. Problem number 24, in which the hypothesis is you are given two circles intersecting in 2 points, and you are asking with parameter involving the parameter p. He is asking the circle passing through PQ and the given point 1, 1. If there is one circle passing through these 3 points, what is the condition is for all values of p, or only all values of p except one value of p, and all values of p except 2 values of p, and exactly one value of p is asking. That means what will be the values of p for which there is a circle passing through their points of intersection and the line and the point 1, 1. Actually, we know that given 3 non-collinear points, there is one and only one circle. Through any 3 non-collinear points, there is one and only one circle itself. Now you have to see whether p, q and 1, 1, for what values of p they are collinear and for what values of p they are non-collinear. Common chord is s minus s dashed. S minus s dash means x plus 5y, x plus 5y plus p square plus 2p plus p square plus 2p minus 5 is equal to 0. This is. Now we know that any circle passing through their intersection, passing through P and Q, whose equation is whose equation is s minus s dash equal to 0 is of the form is s plus lambda into s minus s dash means that is x minus x plus 5y plus p square plus 2p minus 5 is equal to 0. So, that is x square plus y square, s is x square plus y square plus 3x plus 7y plus 2p minus plus lambda into x plus 5y plus p square plus 2p minus 5 is equal to 0. Now, this circle passes through 1 1 also, implies 1 1 1 plus 1 2 plus 3 5 plus 7 12 plus so 12 plus 2p minus 5 plus 7 into this 1 1 means 6 plus p square plus 2p minus 5 is equal to 0. X square plus y square 3x plus 7y plus 2p minus 5 equal to 0. So, now that means 12 minus 5 means 7. So, 7 plus 2p plus lambda into what you would p plus 1 whole square is equal to 0, or lambda is equal to minus of 7 plus 2p by p plus 1 whole square. Now, this is lambda exists for all values except p is equal to minus 1, and if p is equal to minus 1, then the points p, q and 1 1 are collinear so that there will be no circle. So, there is always a circle passing through p, q and 1 1 for all values of p except one value which is minus 1. See, answer is option number 2. The point diametrically opposite the point p1 comma 0 on the circle s is equal to x square plus y square plus 2x plus 4y minus 3 equal to 0 is option number 1 3 comma minus 4, 2 minus 3 comma 4, 3 minus 3 minus 4 and 4 3 comma 4. Right. Now, let solution. Let qxy is diametrically opposite. Opposite to p1 comma 0. So, therefore, the center 1 minus 1 comma minus 2 must be the midpoint of PQ, must be the midpoint of PQ itself. So, therefore, now use the midpoint formula. So, x plus 1 by 2 is equal to minus 1 and y plus 0 by 2 is equal to minus 2. So, that implies x is equal to minus 3 and y is equal to minus 4. So, the diametrically opposite point is simply minus 3 comma minus 4, which is option number 3, itself. So, that is the diametrically opposite point qxy to the point P 1 comma 0, because for any circle diameter opposite point means the center must be the midpoint of the diameter, and one end is 1 comma 0 and the other end is x comma y. This must be the midpoint. So x plus 1 by 2 is equal to minus 1 and y plus 0 by 2 is equal to minus 2. So from which you will get x is equal to minus 3 and y is equal to minus 4. Question number 26 or problem number 26. Here in the problem you are given a circle touching x-axis and passing through the point minus 1 comma plus 1. And then for what values of this, if hk is the center of the circle, then what about the range of k? The range values of k is asking. So you can write that is. So C HK is the center, so that by hypothesis k is the mod k is the radius. Mod k is the radius itself. Now we know that, so therefore, since the circle passing through minus 1 comma plus 1, we have 1 minus h whole square minus 1 comma minus 1. So 1 plus h whole square plus k minus 1 whole square is equal to k square. So that implies that is h square plus k square plus 2hx 2h minus 2k plus 2 is equal to 0. This k square will cancel. Okay. So that implies h square plus 2h minus 2k plus 2 equal to 0. Okay. So therefore, what you will get is this has, because the circle is a real circle, this quadratic must have two roots. That is, since the circle is real, so we have 4 minus 4 into 2 minus 2k is greater than or equal to 0. 4 you can cancel. So that means 4 comes 1 minus 2 plus 2k is greater than or equal to 0. So therefore k is greater than or equal to half. So minus 1 you take to the side. So k is greater than or equal to half itself. This is the answer solution, and the correct option is option number 2. And here see, the only thing is what we have used is the circle equation is x minus h whole square plus y minus k whole square is equal to k square. So that we have used, and this passes through minus 1 comma 1. So that means 1 plus h whole square plus k minus 1 whole square is equal to k square. So if when you expand it, k square cancel. So this is quadratic in h, for which it has got real roots. So the discriminant must be greater than or equal to 0. So it is greater than or equal to 0 means 4 minus 4 into 2 minus 2k must be greater than or equal to 0. So 1 minus 2 plus 2k is greater than or equal to 0. So k is greater than or equal to 1 by 2. So problem number 27. And in this problem we are given two diameters of a circle and its area. Then he is asking the circle equation, whose options, the given options are x square plus y square plus 2x minus 2y minus 62 equal to 0, x square plus y square minus 2x plus 2y minus 62 equal to 0, and x square plus y square minus 2x plus 2y minus 47 equal to 0, and x square plus y square plus 2x minus 2y minus 47 equal to 0. So here circle and center is, and all of you know that center of a circle is always the point of intersection of the diameters. So here the diameters are 3x minus 4y is equal to 7 and 2x minus 3y is equal to 5. So now solving them, 3x minus 4y is equal to 7 and 2x minus 3y is equal to 5. So solving them, this is 3x, you multiply this with 2 and this with 3. So 6x minus 8y is equal to 14 and 6x minus 9y is equal to 15. So solving these two diameters equations, we get y is equal to 1 and y is equal to minus 1 and x is equal to 1. So the center is 1 comma minus 1. 1 comma minus 1. If you can check it. 1 comma minus 1, 3 plus 4, 7 and 2 plus 3, 5. So okay. So this is the center. Now the radius, area is equal to 49 pi, which is equal to pi r square, where r is the radius. So that indicates pi will cancel, r square is equal to 49 or r is equal to 7, because it is positive, r is equal to 7. Therefore, circle equation is x minus 1 whole square plus y plus 1 whole square is equal to 7 square, or that is x square plus y square minus 2x plus 2y. See 49 minus 2 means 47. 47 is equal to 0. So the correct option is C, the circle equation x square plus y square minus 2x plus 2y minus 47 equal to 0. So which is nothing but the correct option is option number 3. Question number 28. You are given a circle C whose center is origin and radius 3. Now he is asking the locus of the midpoints of the chords of the circle which subtend an angle of 2 pi by 3 at the center. And the options are 1 x square plus y square is equal to 1, x square plus y square is equal to 27 by 4, x square plus y square is 3 by 2 and x square plus y square is equal to 9 by 4. And you know that draw OM where O is equal to the center 0 0 perpendicular to the chord AB, so that 𝗪HK, M is the midpoint, M is its midpoint, and this is a fundamental property in the circles. If you draw a perpendicular from the center of the circle to a chord, it will bisect the chord itself. So let 𝗪HK be the midpoint. Chord. Now, since S is equal to x square plus y square minus 9 equal to 0 is the circle equation. The equation of the chord, AB in terms of its midpoints, midpoint is S1 is equal to 0, that is Hx plus Ky minus 9 is equal to H square plus K square minus 9, that is Hx plus ky is equal to h square plus k square. By drawing OM perpendicular to AB, you know that M is the midpoint of AB. So, when M is the midpoint of AB, so therefore, now by hypothesis, angle AOM is equal to pi by 3. Angle AOM is equal to pi by 3. And OA is equal to square root of OA. OM is equal to square root of h square plus k square. Now, from triangle AOM cos pi by 3 is equal to OM by OA. So, this is OM by OA. So, that is square root of h square plus k square by OA means 3. So, that means cos pi by 3 is equal to 1 by 2. So, 3 by 2 is equal to square root of h square plus k square, or that is, so locus of MHK is x square plus y square is equal to 9 by 4. X square plus y square is equal to 9 by 4. So, the correct option is fourth one. Fourth one is the correct option. X square plus y square is equal to 9 by 4. So, answer is option number 4. So, here the only thing is, when you drop the perpendicular onto the chord AB, that the foot of the perpendicular will be the midpoint. Now, suppose the midpoint is HK, then you know that radius is equal to A, and this is equal to square root of h square plus k square, this length, because the HK and 0, 0, 0. So, square root of h square plus a square. So, if you take cos pi by 3, OM by OA. Cos pi by 3 is equal to OM by OA, but OM is equal to square root of h square plus k square by 3. But cos pi by 3 is 1 by 2. So, 3 by 2 is square root of h square plus y square. So, locus of MHK is x square plus y square is equal to 9 by 4. So, hence the correct option is 4. Problem number 29. G comma F is an external point to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. And if the tangents drawn from P to the circle are to be at right angles, the condition is, he has given 4 conditions, out of which we have to find the correct option. So, the options are, first option is g square plus f square plus c equal to 0, and second option is g square plus f square plus 2c equal to 0, and third option is g square plus f square plus 3c equal to 0, and fourth option is g square plus f square plus 4c equal to 0. So, now everybody knows that from a point, if you draw perpendicular tangents to a circle, and that point lies on the director circle of the given circle. Now, you can take, since the tangents from P, G comma F are at right angles, then the point P must lie on the director circle of S is equal to 0. And also you know that the equation of a director circle is also a concentric circle whose radius is stretched by root 2 times the radius of the original circle. So therefore, P lies on x minus g x plus g whole square plus y plus f whole square is equal to twice square root of root 2 times. So twice into g square plus f square minus c. So that indicates, so that implies g plus g is 4g square plus 4f square is equal to 4g square plus 4f square is equal to 2g square plus 2f square minus 2g. So this implies 2g square plus 2f square plus 2c is equal to 0, or g square plus f square plus c is equal to 0. So the correct option is option number 1. Problem number 30. The length of the intercept of the circle x square plus y square minus x plus 3y minus 22 equal to 0 on the line x minus y minus 3 equal to 0 is options 2 root 6, second option 4 root 6, third option 3 root 6, and fourth option is 4 root 3. Now you know that center O is equal to half comma minus 3 by 2 is the center, and radius is square root of 1 by 4 plus 9 by 4 plus 22, which is equal to root 98 by 2. Root 98 by 2. Or this is same as you can write as 2 will cancel, root 98 by 4. So which can be written as square root of 49 by 2, or that is you can write as root 7 by root 2. Whatever be the you can name. Now we know that suppose M is the midpoint. M is the midpoint of the chord AB, of the intercept AB. Intercept AB. So therefore, OM is equal to now square root of 1 by 2 plus 3 by 2 minus 3 by square root of, modulus of this by root over 1 square plus 1 square. 1 square plus 1 square. So this will be 4 minus 6, 2 by 2 by 2 means 1. So 1 by root 2. See, half plus 3 by 2 means 2. 2 minus 3 means 1 modulus 1 by root 2. So therefore, length of the intercept is equal to twice AM. So that is twice. AM means 49 by 2 minus 1 by 2. Minus 1 by 2. So which is equal to 48 by 2. 48 by 2 means, so this is twice 48. 48 by 2 means 24. Root 24. Root 24 means 4 root 6. That is equal to 4 root 6. 24 is 4 into 6. 4 means under square root it will be 2. So 4 root 6. Here what you have used is nothing but, if M is the midpoint of the chord AB, then OM is perpendicular to the chord. So here you have used only right angle Pythagoras theorem. Pythagoras theorem, this is radius. So radius square is equal to the sum of the squares on the sides. The correct option is 4 root 6.